Okay.
Who did that? I can explain number one if you need me to. The first warm up. If they want to hear some of their peers.
Go ahead.
Oh, thanks. Okay. So I feel like Mrs. Donahue, she always hits the color.
It's not. It's the line.
It's the line that I changed the thickness.
No, not that line.
Like this. Then she goes like that.
And then she caps it. No, then she caps the lines again.
Oh, okay. So if A is equal to 2 and B is equal to -8, you need to substitute this in for each other. So B is -8 over 2 times.
Wait, that's wrong. That's wrong.
You see what?
B is negative. Oh, sorry guys. Sorry.
Change it to a plus. Yeah.
Oh yeah.
Why are you erasing it too?
Oh, hold on. We gotta restart. Let's just restart. Goodness. Okay. So then you have -8, but this is also a negative. So what we have to do, this becomes +8
There you go.
over 2 times 2.
What is it?
Does anybody know what 2 times 2 is?
5.
No. 4. So this crosses off. It's this is 4. So then 8 over 4 is equal to 2.
Well, what is 2 equal?
Yeah.
What?
Isn't the whole thing?
Where did X go? Did X just like
X, it should be X equals.
Sorry, X equals 2.
And there you go. Thank you, Abby. Thanks, Abby. All right, clear as mud. Okay, good. So, but sometimes it's good to see a mistake made because, I mean, that was a question before you got up here. And so, you know, it's good. But, you know, underhanded compliment there.
I
All right.
didn't even see his thing.
So, then it says find y if y equals, and it gives this whole expression. Sorry. Oh, you want to come up and do that one?
Yeah.
Okay.
Wait, you can use the X value.
Yeah, yes. This is supposed to be all one big problem.
I thought it was a separate problem. Okay.
Well,
So, keeping in mind that X is 2, you do y equals 3 times 2 is 6.
No, you don't do it that way.
Where's the power?
Yeah.
2 to the second power is 2 times
16.
4. That's 4. So 3
That's a
times 4 minus.
What
is 4 times 2? 8. Yeah, Caitlin. Plus 5. And 3 times 4 is 12. So y equals 12 minus 8 plus 5. So what's 12
9.
minus 8?
12 minus 8 is
9.
It's 4. So y equals 4 plus 5.
9.
Y equals, what does it equal?
9. 9.
Does anybody know?
9.
9. Yeah, Maddie, you're right. Y equals 9. Good job, Maddie. Good job.
All right. So what we just you're so distracted by the teaching. Yes. Okay, so good question. So going back to the very first step, why did we do 3 and 4? So I'm gonna erase part of it.
Oh,
Okay. I'm gonna put this in. So y equals. So first of all, the x is coming from this first half. So I'm gonna put x in there. So I'm just gonna show a few more steps. And Kinsey did. She did it right. It's just I want to show.
stop.
Okay, be nice. Thanks for coming up. So, okay, guys. So we put the 2's in. You're okay with that? I'm assuming. Well, that's where I wanted to stop you guys with the 2 is because we have to follow order of operations. So we have to do exponents before we can multiply. So that's why I just wanted to show that step. She didn't do it wrong, it's just she didn't show that step. So we have 3, 2 to the second is 4. Whoops, that should be minus, sorry.
See,
Even I made a mistake there. And so that's where she got 12 minus 8. Does that help clarify, Paige? So like just the exponent before the multiplication is all. So just try to show that. So what we just did in our warm-up, we have to do for every single problem today. Yeah. Yeah, and like the x and the y thing, like so being able to use this equation here that Abby showed us, very succinctly there, that equation, that's going to get used today when we're graphing our parabolas. So, so the warm-up, although it took us like 20 minutes to do, we have to do every single problem. So if you look at our homework for tonight, the fact that it's 6 problems is because that's one part of the whole homework. So what we're going to do today is talking about solving quadratics by graphing. So we're graphing parabolas today to solve our quadratics. So what a quadratic is something that looks like this. What makes this a quadratic? Does anyone know? Like, why do we call them? I know the quad is confusing. The quad, don't think of 4 with quad for whatever reason. It's the exponent. So the fact that the exponent is a 2 makes this a quadratic. The highest power is a 2. Guys, close up the computers if you guys are on other stuff. So something that's a quadratic has an x squared as the highest power. We're going to be solving quadratics today by graphing. We're going to also solve by factoring, which we did in algebra. You can solve by square root. We're going to solve a lot of different ways for quadratics. So to solve a quadratic like this, we're going to look today for the x-intercepts. So we're going to look for the x-intercepts. Where do the x-intercepts show up on our graph? Where the x-intercepts show up? Yep, on this axis, the x-axis.
On the graph.
So we're graphing today. We're looking for the points on the x-axis. And when we graph a quadratic, it's a parabola, which is a U-shaped graph. So it's either going to be an upward facing U, like a smiley face, or a downward facing, or me face. So we're going to be solving them today. Now solutions are called, we call them x-intercepts or solution. But if you were to like Google this, like if you were looking for how to solve quadratics, they might use other words. They might use roots or also zeros of the function. So those are also names of solutions for quadratics.
That's what the 8th grade math teacher would say.
What's that?
Zero of the function.
Oh, yeah. I don't use that very often. I don't know if that's a bad thing, but I don't. All right. So in terms of our parabolas here, I'm going to show you guys 3 different types of parabolas. So, and when you draw them, you're going to try to want to draw them similar to mine, in that I want to show the different types of intercepts we can have. So this first one, I drew this intentionally this way so that it would have how many x-intercepts? 2. This has 2 x-intercepts. So the zeros or the x-intercepts would be those 2 spots. So if you can draw it so it has 2 x-intercepts, doesn't need to be exactly those spots, but that it hits it twice. What other types of number of intercepts? So this has 2 solutions. What's another option? What's that? No, we always want them to be x-intercepts. But for having two solutions, could there be more? Could there be less? Any thoughts? Yeah.
Maybe then it has one solution if it only goes through the y-axis.
It's not going to still be the y-axis. It can go through the y-axis, but it's only going to touch the x-axis that one time. Does that make sense? So it has one solution if it only touches that x-axis and then kind of turns back around again.
Oh, so it's like.
And again, the solution is the x-intercept still. It's not the y-intercept. The y-intercept is a nice to know point, but we want that x-axis point.
Nice to know.
Nice to know.
The
Nice
neighbor.
to know, yeah.
The neighbor axis.
Yeah. All right, and then what else do you think?
Zero solution.
There is a zero solution. Or
I don't need to do that.
and so it's possible to get no answers for these. And that means what about my parabola? It doesn't touch the x-axis. It doesn't exist. So it could be like above or it could be above or it never touches the x-axis. So that's considered no solution. Or it could have an imaginary solution. I know. Yeah, that's a real thing, imaginary solution.
He's a little too advanced.
Okay. So we're gonna solve by graphing here today. We'll take a break midway through to do some whiteboards. Because I think it's only like, although it looks nice outside, I think it's only like 30 degrees, yeah. So, and probably windy, but. So like we went to bed last night without the heat on because our house was still warm from having like the oven on for dinner or whatever. Our windows were open. In the middle of the night, I woke up and Peyton had Griffin had come into our room and Peyton had gotten out because it was less than it was like 50 degrees in our house. Like, so everyone was freezing and like they couldn't figure out why, but their window was still open. And so like their room was like, you could see your breath in there. It was so cold. And so they were all like scrambling for heat. So we turned the heat on finally, but it was warm out yesterday.
My dad's like, no heat November, and then my stepmom turns it on.
That's awesome. I try to wait. I mean, we don't turn the heat up. Like our heat goes up to 64. Like it's as high as we keep it.
Oh, that's
I'm just like, you can get ours.
I don't know. My kids are always warm. I don't know. We have a small house.
The boys share a room?
Yeah, because they choose to.
Oh.
They have bunk beds. So. I know, but Peyton's getting too big for a bunk bed. He's like, I mean, he's almost 5'11". He's climbing in a top bed. Yeah, they both. Peyton's head is very large. Yeah, it's a large head. Like his head is bigger than anyone else in our family, and it's always been that way. So it's like when he gets a fitted baseball hat, he gets like the biggest one on the team. So. All right, so we're gonna solve by graphing. Now, I wrote this is kind of like the standard equation. So it equals 0, and from that you can tell what A, B, and C are, kind of like your y equals mx plus b. So I'm gonna actually list what A, B, and C are. When I get a problem like this, I'm gonna have a lot of work to do, and so I have these steps that go with this. I wanna list what A, B, and C are, just so I know for the rest of the problem.
Where are A, B, and C?
So we don't know that quite yet, but it's based off of this equation. So the A is what's in front of x squared. So what would A be in this case?
1.
1. How about the B? Negative 4.
Oh, I remember this
And
stuff.
then C? 3. Yeah, we've used this. Okay. So the first thing we're going to do is talk about the graph. And the graph is going to be either pointing up or down, depending on the A value. So the A value, if A is positive, it's going to be happy. If A is negative, it's going to be sad.
What if it's not happy or sad?
Well, numbers are either positive or negative, so we don't have a.
Even zero
Okay,
is a
but we're talking about the A value. Okay, so real quick here, guys. Good question though. So A is positive or negative. So A is a positive 1, so this would be a happy graph. So the question was, what if A is 0? What happens to my equation if A is 0? No?
It's neutral.
Well, so the x squared would be gone. If there's nothing in front of, or if it's a 0 in front of x squared, so I have 0x squared plus whatever. Let's do like 5x minus 2. This isn't even there anymore. This equation is no longer a parabola. It's become a straight line.
Oh,
So we don't have to worry about parabolas then. So A shouldn't ever be 0 if it's a quadratic. So that tells us this graph is going to be happy. We're going to find the vertex of the parabola. The vertex is the center of the parabola. And the equation we used in the warm-up tells us the vertex. And that's x equals negative b over 2 times a. So that formula that we had in the warm-up wasn't just some random formula. It's meaningful because of the vertex.
I remember.
liar.
So I'm going to figure out the vertex. And what the vertex is going to be is I'm going to get my x coordinate from there, and then my y is going to come from substituting the x back in. So we'll figure that out in a second. So we're going to figure out the vertex. So just like our warm-up, negative b over 2 times a. Well, b is actually negative 4, so when I put it on the top of the fraction, it'll look like positive 4. Over 2 times a, which is going to be 2. 2 times 1. So what's the x coordinate of my vertex? 2. So it's 2 comma something.
Just like our problem.
Now, once I know that 2, I have to take that 2 and substitute it in to find my y coordinate. Well, I can just put it in here. I know this equals 0 because we're trying to solve it. That's essentially how we find our y. So we're going to take this and put it back in here. So I'm going to have 2 squared minus 4 times 2 plus 3. 4 minus 8 plus 3. I believe negative 1. Yeah.
Yes, ma'am.
So I can put that dot on the graph. So 2, negative 1. That's my vertex. Now, through this point, there's also something called the axis of symmetry. So this is also called the axis of symmetry. Lots of names. The axis of symmetry. And so what symmetry is obviously it's the same on each side. So through this line, I know the graph is going to be symmetric. So if it goes up, the other side's going to go up the same way. If it goes down, the other side's going to go down the same way. It's function dancing.
Huh.
So once we have our vertex, now we're going to make a table of values.
I hear enough
So from Will.
I hate it so much.
You hate what?
Will. He
He
has like
knuckles.
500 knuckles when he grabs
Really?
his knuckles. Go like,
He tries every time he's on it.
bang with that neck.
I remember.
Okay. Now, we're going to put the vertex in the middle of our table because the vertex is in the middle of our graph as well. So that 2, negative 1, we're going to put that in the middle of our table. We already have part of our table of values done.
Is it always
So-
going to be 5?
Yeah, I typically ask you guys to graph 5 points. Sometimes you want to do more or you need to do less just because it doesn't fit. The ones I typically give you for homework, 5 fits pretty well. So that's why I sometimes pick and choose my homework problems. So we're going to pick other values close to this x. So I would stay really close. The further away you go, the bigger this graph gets or the smaller it gets, and like the numbers get really huge. So I basically just count up and down from here. So I have 2, and go 3, 4, and then 1 and 0. And we need to find these y values based off of the x's. So we're going to take these numbers and substitute them into our equation again to find our y's. So if I start with like 3, I'm putting 3 in. So 3 squared minus 4 times 3 plus 3, right? So 9 minus 12, negative 3 plus 3 is 0. Is that right? 3, 0.
Do I sense a pattern?
Okay. Now, okay, hang on a second though. For our axis of symmetry, remember, so like, and you don't need to draw this line, but there should be symmetry through this line. So again, if I go up 1 and over 1 over here, what's going to happen on this side? You're going to it's symmetry, so exactly the same. So if it's up 1 over here, it should be also up 1 over 1 here. So there should be symmetry on either side. So I already know that 1 will also be 0. So there's symmetry among the y coordinates. So you really only have to do half the numbers because the other one should match.
Oh,
Interesting.
this is really ringing bells now.
Okay, good.
Interesting.
All right, which one do you think is easier to do, 0 or 4?
4. 4.
What's wrong with you people? 0. If you put 0 in, those both become 0.
Okay, 3. You really need a
So it's just 3. You want the challenge? Oh God. 3. So 0, 3.
What is wrong with you?
So 0, 3. Now again, symmetry.
Symmetry.
I'm up over a 3 over here. What needs to happen on the right side then?
On the other side.
On the other side at 3 as well. So there should be symmetry. So now we have our U-shaped graph. Now it might look a little like a V. Try to make it look like a U as much as you can. Now, if you were really curious and wanted to do some more points, you could. You don't need to. 5 is fine with me. That's okay. As long as you don't like use a ruler, it should be fine. All right, last thing here. Step 3 is we want the solution. Don't forget, what are our solutions? Where do we find the solutions? The x-intercepts. So what would our x-intercepts be in this case?
0, 1, and 0, 3.
We have that flipped. So
1,
x
0,
is 1 and x is 3. The x-coordinate's always first. But the x-intercepts are our solution. So those would be your 2 answers in this case. But practicing the graph is going to be important and helpful
For our upcoming life.
All right. Do you want another example on the whiteboard or on this board, or do you want to do some whiteboards for a little bit?
One more example.
Keep going here. Okay. We didn't decide on whiteboards. We're staying with this board. Okay. All right. So again, as we go through this, I like to list what A, B, and C are first, just so we all know what we're talking about here with this. So A, B, and C. What's A in this case? 2. 2. B is?
Negative 16.
C is?
30.
30.
That's what that is. Yeah. She was 40 the other day, and now today she's 30.
I just want to get younger, yeah.
All right.
West plus.
So, do we know if this graph is happy or sad?
Happy.
It's happy because the A value is positive, so it should be pointing up.
Oh yeah, I knew that.
A is positive, happy graph. Just realized I don't think I have any, oh, I do have a negative one on the bottom, but.
So you know which one's negative.
So, our first step is we have to find that vertex.
So you can do the equation.
So we're using negative b over 2 times a to find our vertex. So again, b is a negative 16, so when I do that, it's going to become positive 16 over 2 times a. So the x coordinate is going to be 4. Once I have the x coordinate, remember we have to substitute that back in to find the y. So we're putting that 4 in, but remember to follow order of operations. The 4 squared is 16 times 2 is 32. This is 64, negative. I believe we get a negative 2. What you guys got?
I got negative 2.
You too.
2. So that's our vertex. That's where everything's going to start from.
Good spot.
So I'm going to make my table of values again with 5 values. And I'm going to put my vertex in the center.
Does it have to be in the center or can we like put it on the top?
I think it makes it easier if it's in the center for the symmetry part of it. About 19 years of teaching experience has taught me that.
So the first year she started at the top. Then she worked her way down and now she's in the middle.
So you could put it at the top.
So you could. I'm going to get crazy. All right, how do we know what other numbers to pick?
Let's just
go
go 1, 2,
order.
3, 4, 5.
So you go right in order. So 4, 5, 6, and then 3 and 2. Again, we want to stick close to that vertex. If you go too far away, the numbers can either be really big or really small and be way off our graph. We want to stay somewhat close. And again, I design these, or I make sure I pick problems that way intentionally so that you don't have them, that you have to graph like up to like 64 or something like that. So we can start with like, I don't know, 3 or 5, either one.
I'll just go with 3.
5.
Probably say 3 just because the number's smaller. But
Yeah. Can you
all
start
right.
at 2 or 6?
So 3 squared is 9. Times 2 is 18. Then this is a negative 48, I think. So not negative 30 plus 30. I believe it's going to be
0.
0.
That means 5 0 too.
Right. So that's why we like picking numbers that are close by there. So this is also going to be 0 because of that symmetry. Whatever happens on one side happens on the other. Okay. All right. Then we have 6 or 2.
6.
See, I don't want to multiply the 6 in my head. So I'm going to go with 2. So 2 squared is 4, times 2 is 8. Negative 16, or times 2 is a negative 32. So 8 minus 32, negative 24. Plus 30 is 6. And then I know 6 is also going to be 6 because of symmetry. So our solution again is where it crosses the x-axis. So where are those 2 spots?
3 and 5.
x is 3, and x is 5.
Okay, I actually kind of like doing this, which I never thought I would say in math, but I don't mind doing this.
The only issue is if your vertex is wrong to begin with, the
Then
graph's gonna go crazy wonky. So that's usually your clue. Like if you're like, your numbers are all over the place, you're not really making sense, it's probably worth going back and looking at your vertex again. That's the solutions. That's where it crosses the x-axis, remember. Well, no, if you're just looking for the zeros, you just want to know what the x's are. That's what would make this equation equal 0.
I'm good for whiteboard.
You gonna try whiteboards? Okay. Why don't we do some practice with whiteboards? You guys want to grab those?
I was like, it's just. Yeah, so it's like. Hey, I got this one.
You wrote that.
I guess.
Dino chicken nuggets.
I know we are playing the elementary show. Did you buy those tissues? You're using the good Kleenex? Did I?
It's okay. It'll be okay. All right. So we're gonna work on finding the vertex, because I think that's the toughest part of this. So I want you guys to give me the vertex for the equation. So the x coordinate and the y. So both parts. So you're gonna want the negative b over 2 times a. To grab. Yeah.
You're so funny.
It's like, find it.
It's right there. Okay. One marker. All right. Find the vertex, please. So that can equal 0 or just be y, but that's the y is there. And then, so that's the first half, that's the x coordinate. Now put that back in to find y. So put it back into that original equation. Well, that should be a negative b over 2 times a, sorry. And then negative 6. Okay, so when you put your x coordinate back in, remember you have to square it first. Think about what negative 1 squared would be. Are we making a table? Nope, you're just finding the vertex. Yes. Yes. Your y coordinate's wrong, so you have to put your x back into this equation. Good job. No, you're close. Yes. Yes, good job, Bennett. Yes, good job. Yeah, good job. Yeah, no, you're good. Oh, okay. I just have to do some Yeah. Okay, guys. I'm going to talk through it up here. No, let's talk about it. Okay, so when I go to put this into negative b over 2 times a, make sure you guys are listening if it didn't go well for you. Opposite of b is going to be a negative 4 over 2 times a, which is 2. So this is going to be negative 4 over 4, which is going to be a negative 1. That's your x coordinate. Then I have to take that and put it back in to find my y. So y equals be 2 times negative 1 squared plus 4 times negative 1 minus 5. So negative 1 squared, careful, it's going to be positive 1. So 2 times 1 minus 4 minus 5. 2 minus 4 minus 5, so negative 7 is the other half of our vertex. Okay? So let's kind of work on that a little bit more and make sure everyone's there before we do something different. The whiteboards are a little hard to do like a whole graphing thing, partly because there's no graph.
What?
And just a heads up, I think this one would be a bad one to graph. So if you're like worried that doesn't make sense, yeah.
Yep.
Yes. Yes. Yes, good job. Yes. Yes. Oh. Yeah, except this should be y over here in the lower right corner. X equals for that. Should be a y. Since this is negative times a negative 12, it'll be a positive 24. Yeah. You're good. No. Yeah, so the vertex usually will not be like a equal number. So negative b though, careful. I think you were A, B, and C like. Okay, so it's negative b over 2 times a. You flip your A and B. So b should go on top.
Yeah.
Careful, negative 2 times negative 12. Yes. Mm-hmm. It should be a negative 12. Negative 3 times 4. Yes, Abby, good job.
Thank you.
then a negative number.
Kenzie, I know you.
I'm gonna start working through it up here. I know some of you guys are still working. So opposite of b is gonna be 12 over 2 times a. So 12 over -6, so a -2 for my vertex. Once I have that, I can substitute that back in to find my y. So this would be -3 times 4 plus 24 plus 5. So we end up with 17. Thank you. All right.
One more.
One more. Okay. Let's actually. Let's actually use this equation and make our table of values. So I want you to fill in the rest of the table of values.
Oh. She did it like that.
I know, I changed it up on you guys.
Oh, it's the same problem?
Yeah, so using that same problem, use that vertex. I put it in the middle. You want to pick numbers around that vertex. Pick the numbers right around that vertex. Holy speedy, yes, good job. Yes, good job. Yes, good job. Oh, I bet it actually I didn't. I didn't hear that, but yes. So you're picking other numbers right around it, which looks like you did, right? Yep. And now you're going to pick those numbers and put them back into the equation, but also use the symmetry. You only need 5 of them. So you're good. You're good. Yes, good job. Yes, good job. Yeah. Once you're good, you can do the whiteboards. Next way. So, yeah. Maybe we'll talk about it up here, but be careful. 0 should be a really easy one to do. Try 0. Yes. Yeah. 17. Now you're picking other points around it. So what would be a bigger point? What would be a smaller point? Numbers nearby. Yep. What's bigger than -2? What's smaller? No. No. We'll talk about it up here. Yeah. Give me that. What? That's 0.5? Yeah. No. You're just substituting these numbers in to that equation.
Oh, she does 9.5.
All right. So on this problem, I like starting with 0. 0 is really a nice one to start with because this is 0, so I'm left with 5. There's symmetry on the other side of this that I know is also going to be 5. Then I can substitute in 1 or -1 or 3. I did -1. So this becomes 1, so -3. This is 12. end up with 14 here, and there's a mirror image on the other side. Okay? So, all right. Let's actually skip down to example 4, if we could.
Oh. I didn't know what you were saying. You said like a pretty nail. You're pointing at your eyebrows.
I thought you said nice glasses. I don't think you wear glasses.
Okay. So what's the issue with example 4? Do you guys see it?
There isn't
There's not
a
a zero.
C.
There's no zero.
There's no 0. It doesn't equal 0.
Oh.
So what do we have to do to make it equal 0?
Minus 6.
Add 6.
Add 6 of us.
I thought you said it was 0 is a flat line.
No, if the A is 0, it's a flat line. Not if it equals 0.
So now we have our C.
0, 6.
So yeah, now we're able to see A, B, and C.
0, 6. C is 0.
All right, so we move the 6 over so that the equation would equal 0. So now we should be able to tell what A, B, and C are. What's A,
1,
B,
4,
C?
6.
Okay. So we're going to do our negative B over 2 times A to find our vertex.
Oh, it's a neg.
So,
Negative.
so it's going to be a negative 4 over 2 times 1. So negative 4 over 2, so it's going to be a negative 2. You okay with that? Then we're going to take that and substitute it back in to find our y coordinate. So negative 2 squared is going to be 4. It's going to be a negative 8. So negative 4 plus 6. 2. Negative 2. Oh, that's not in the right spot. Negative 2, 2. And just like we just did on our whiteboards, now we want to pick points that are close to that negative 2. So you can go either up or down, negative 1, 0, negative 3, negative 4, it doesn't really matter.
What if you pick like if you put like negative 3 on the other side?
Well, I think it just helps for the symmetry factor, that I know that these are the same distance apart. So that's why I set up my table that way. It doesn't really matter where you put them on the table as long as you're able to decipher where everything's supposed to
So
go.
if you put like negative 3 on 2 and put negative 1 on 4.
Yeah. If you want to, yeah. All right, I like using 0, because 0 makes these first two 0. So then the y is just going to be 6. If you haven't caught on already, the C is always your y intercept, 0, 6. That's a little nice to know thing. So 0, 6, so over at 6, the other one then is going to be negative 4, 6. Because of that symmetry. And then we can either try negative 1 or negative 3. I like working with smaller numbers. So negative 1 squared is 1. So it'll be negative 4. So negative 3 plus 6 will be 3, right?
Negative 3 plus 6.
Negative 3 plus 6 is
This is the one that
negative
is 3.
3.
It caught me off guard for a second.
All right. So where is our solution?
They don't exist.
There is no solution for this one. So there's no answer because it never touches the x-axis.
No soul. See, with these kind, you actually have to do it to find out if there's no solution. You can't just be like,
Yeah. So no solution. One thing they do ask you in your homework is where's the axis of symmetry? Kind of going back to that, axis of symmetry is the line that goes through that middle. So yeah, the axis of symmetry, the x equals negative 2 is called the axis of symmetry. we are going to do example 5, so don't put all your stuff away yet.
Hey, you pushed my paper off my desk. Stop.
All right.
Oh, the word problem.
Yeah. So, word problem. So, hey guys. So it says an arrow is shot upward. The height of the arrows in terms of time is given by this equation. Why does this show up in this section? Why would this have anything to do with what we're doing right now? Because it makes that U. So okay, yeah. So if I shoot an arrow up into the air, it's going to go up, and there's something called gravity that also sends it back down. So it has a parabola shape to it, and that's actually a place where when people are like, when will I ever need to know this in life? Like, I tell you guys that truly engineers use parabolas. Like, I mean, or someone who works with, I mean, I have a friend who's an aerospace engineer. I can tell you she uses parabolas in her everyday job. Maybe not everyone, but, you know, like, obviously is something that could apply. Yeah.
It's still a parabola if you straight out.
Yeah, it still will have some sort of like, well, if it comes straight down, it has a turn though at some point, so it's just a really skinny, I don't know.
It comes straight down backwards.
Oh no, I think it would turn because of the little things on the end.
I don't think we don't know.
And like, because the point of the arrow is heavier than the rest of it, so that will fall first. As far as I know. Okay.
We're spending too much time.
Okay, so, okay guys, it says, find the time it takes for the arrow to reach its maximum height, how high will it go, and then you could even talk about how long it'll take to get to the ground. I'm going to tell you guys right now, this might not be the nicest numbers in the world, and we might not even want to spend time graphing it because we want to know that maximum height. So, maximum height, where do you think that's going to be on our graph?
The top.
The top. What do we call that point? We have a name for that. It's called the vertex. The very top of our parabola, when the parabola is upside down, is called the vertex, just like the very bottom is called the vertex. So we want to find the vertex of this parabola. Now, in order to find the vertex, we're going to use negative b over 2 times a. But if you look at our equation is a little bit out of order. Does anyone tell me what the a and b are and c? What do you think? Yeah, so whatever is by the x squared or the t squared is going to be our a. So in this case, a is a negative 16. How about our b? It's going to be 50 because that's what's next to the x term or the t term. So that's going to be our b is 50. So we've figured out a and b. Now, what's c? 0, because you're starting from the ground, so that's the very bottom. Okay? Now, the vertex is x equals negative b over 2 times a, but rather than using x's, we're going to use t's, because t is time. So negative b, so that's going to be negative 50 over 2 times a, so 2 times negative 16. And the 16 is not like an arbitrary number. That's actually the force of gravity, like pushing it back down on the ground. That's a negative 32. I'm actually, so negative 50 over negative 32. So here's where our decimal comes in. What's t going to be? 1.562. Is that what you said?
Yes, 1.562.
Okay, so 563, let's call it. Okay, and so what is that? Time, so that's seconds. So it takes 1.56 seconds to get to the top of our parabola. So our arrow, again, I don't need us necessarily to draw it. Whoops, not 1 comma. 1.563, comma, we want to know where the maximum height is. And that's what the h stands for. So we're going to take that awful number, which is not so great, but we can put it back in and figure that out based off of our equation. So we're gonna take the 1.563 and put it back into that equation. And we're gonna like follow our order of operations, so we have to square before we multiply. So thank goodness for a calculator, because we want to do this in their head. What'd you guys get? Got like 39.1. So the height then would be like 39.1, I guess it doesn't say, I'm assuming it's meters. It might be feet, but we'll go with meters.
Because.
Meters sounds more exciting, that's really high. Okay. So I'm gonna get you guys some graph paper. You're gonna have way more graphs than you think.
How many ounces are in a cup? 32?
I think so. 16 is a pound. Is a pound a cup?
I thought there were 8 ounces. How many ounces?
Then what's 32 from?
8. Yeah.
32.
Oh, wait. There's 32 2 cups?
No.
4 cups?
Yeah. There's 32 in 2 pounds.
Is there 32?
Nothing's 32, Abby.
What? I swear something's 32.
Thank you.
What's the significance of 32?
Honey, get a haircut.
Oh,
Like that?
no.
Maybe a little.
This is too advanced for me. I only know algebra 2.
Remember that?
I don't even really know that.